Hi, this is Professor Fernandez, and this is Lesson 3, Video 3. The topic is composite functions, and we'll be working here on example B.9 from Calculus Simplified. That is example 9 in the Appendix B. So let's see what's going on here. We have a f of x function and a g of x function. They're both given to us, and we want to find different combinations of their composition. So we're going to review really quickly what this composition looks like. So the first thing to do is f composed with g. You might remember this as fog of x. So at a specific x value, this is defined as f of g of x. Okay. So that means that I'm going to change colors here to make it a little bit more clear as to what's going on. That means that we're going to take the entire g of x function over here, and we are going to substitute in for everywhere we see an x in f of x. Okay. So what's going on with f of x here? Let's look at f of x. F of x is literally x minus 1. So if instead I'm looking at f of g of x, right, then everywhere I see an x up here, let me use this in red, I'm going to put g of x. Over here, g of x. Okay, so f of g of x is g of x minus 1. Right, and then I go over here and I say, oh, what is g of x? G of x is 1 over 1 plus x. So 1 over 1 plus x minus 1. Great, you could stop here, but just again to help you review some of the algebra, I'm going to combine this. And how am I going to combine this? I'm going to find a common denominator. So 1 plus x. Okay, so I can do that effectively by changing the second term here, this negative 1, into a fraction involving 1 plus x. So I'm going to multiply by 1 plus x in the denominator, numerator. That doesn't change anything. And now I can see when I combine them that this first term here contributes the 1 from the numerator. So that is here. And then this second term here contributes this part. So minus 1 plus x. Okay. And then I distribute this negative 1. So what do I get? I get 1 minus x, still divided by 1 plus x. These 1's go away, and I get negative x over 1 plus x. Okay, this is just a little bit nicer to work with, right? If you want to find domains, if you want to find intercepts and stuff like that, it's a little nicer to work with than the original form we had, which was this minus 1. Okay, but again, admittedly, that was just to help you review some of the algebra here. All right, so now let's do the next one. So g of f of x, similar thing. The outside function is g, evaluated at the inside function, f of x. Okay. So now we're going to do something different. We're going to go to g of x first, and then we're going to put in f of x everywhere we see x. Okay, so I'm going to zoom in, make it especially clear here. Here is g of x. Everywhere I see an x, I'm going to put in f of x. So the only x is down here, so I'm going to put in f of x over there. Great. And this is what I'm plopping in over here. So I get 1 over 1 plus f of x. Okay, great. And then now that I have done that step, I can go back to f of x and just substitute what it's equal to, x minus 1, in down there. So I get 1 over 1 plus x minus 1. All right, and this simplification is a little easier. So here I just have a 1 minus 1, so that goes away, so I just get 1 over x. All right, so I'll start boxing my answers here so we can tell what the final answer is from the rest of the clutter. Awesome, so last one, if I figure this out, this is still the outside function, of x equals f of, and then now the inside function is again f of x. You might say this is really strange, but it's totally fine, right? It doesn't matter. The outside and inside function don't have to be different. They don't have to be the same, right? They could be whatever they are. They are free, if you will. Okay, so f of x. Here is f of x, x minus 1, okay? So we can think about this composition in a different way. Just to show you, in the previous two, I've been, going back up here and substituting in for x to show you what's going on. But in this last example, I usually try to teach you some new strategies throughout the examples. In this last example, we're going to substitute the function itself. Okay, so what is f of x? It's equal to x minus 1. There it is up there. So I'm going to put it in here. This is another way that you can think of function compositions. So what does this mean? Right? We're used to f of x equals something involving x's. Right? This is f of x minus 1. So everywhere I see an x, I'm going to substitute x minus 1. So that's what this means. Okay? So I'm going to go back up to f of x. Okay? And I am going to substitute in an x minus 1 here. Okay? So everywhere I see the x, there it is, I put in x minus 1. So what results is x minus 1 and then minus 1. All right. So then this is another simplification that we can do right away. So x minus 1 is x minus 2, and that is our final answer. All right, so now I'll zoom out so you can see all three examples, and I'll just review them really quickly and just some quick little takeaways. This is a way that you can do compositions which I think, and this is the reason why I showed it in the third example, I think requires sort of a bit more familiarity and proficiency with composite functions. So I generally suggest to students that they try these two ways because it's a bit more direct, right? F of g of x, well, everywhere you see an x, put a g of x. So that gives you that. And then you have another step, which is everywhere you see a g of x, right, put in that. So doing it, the way that I've done in A and B is kind of a two-step process. It takes a little longer, but that's okay because it kind of makes it a little slower and it helps you not make any errors along the way by telling you exactly what you have to do. Once you're here, you say, oh, I don't know, I haven't substituted in g of x, right? So I have to do that, and that's the next step. This one down here, notice that, the amount of work, sure, the simplification was simpler, but the amount of work required was a little less. That's because it's a little faster. But again, you have to be comfortable substituting in for x some other expression involving x, So it's kind of like saying x is becoming x minus 1. That can be confusing, right? So that's why, again, I left the strategy as the last one. But truth be told, any one of these three, or two, I guess, any one of these two ways of doing compositions works. So figure out what works best for you, try a few practice problems, and then stick with that one and then keep practicing. Okay, see you in the next video.